What are waves? Mechanical waves are disturbances which propagate, move through a medium, such as a vibrating object in a material medium, and are transmitted by the particles of the medium vibrating to and fro. Such waves can be seen or felt and include waves on a rope or spring, water waves and sound waves in air or in other materials. When we drop a stone into a pond, we see on the surface of water ripples spreading outwards from the place where the stone landed, with a splash. As the ripples spread, the water surface moves up and down. These ripples are examples of waves. Waves transfer energy. The energy moves outwards from the center, but the water itself does not move outwards. If you look at an object such as a leaf or a cork on the surface, we will see that the object moves up and down because it receives wave energy during its passage, but the wave does not move the object horizontally. Types of waves. There are two types, transverse and longitudinal. Transverse waves. In a transverse wave, the direction of the disturbance is at right angles to the direction of travel of the wave. If we waggle the end of the slinky spring from side to side, we are sending energy from one end to the other. This energy is transmitted by waves. In a transverse wave, the direction of the disturbance is at right angles to the direction of travel of the wave. A transverse wave can be sent along a rope or a spring by fixing one end and moving the other rapidly up and down. Longitudinal waves. A longitudinal wave, the vibration causing the wave is parallel to the direction of travel of the wave. In a longitudinal wave, the particles of the transmitted medium vibrate to and fro along the same line as that in which the wave is traveling, and not at right angles to it as in a transverse wave. A longitudinal wave can be sent along a spring, stretched out on the bench and fixed at one end. If the free end is repeatedly pushed and pulled sharply, as shown in figure. Describing waves. Waves are described by the terms amplitude, wavelength, frequency, and period. The symbol for wavelength is a Greek letter pronounced lambda. Terms used to describe waves can be explained by imagining an idealized wave as shown in figure below. This diagram helps us to understand the meaning of these terms. Undisturbed position. Crest. A wavelength is the distance between two crests. The wavelength is measured in meters. Amplitude is the height of a crest measured from the undisturbed position. The amplitude is measured in meters too. Frequency is the number of waves produced each second. The frequency is measured in hertz. Frequency of 1 hertz means a source is producing 1 wave per second. Frequency of 2 hertz means a source is producing 2 waves per second. Period is the time taken to produce 1 wave. The period is measured in seconds. The frequency and time period of a wave are linked by this equation. The period of a wave is the reciprocal of the frequency. Now it is your turn.